over to kinetics. First thing we're doing is the K units. What you would do is you would want to find the order. Who asked me about this? Okay, pick a number between 0 and let's say 4. And it can include 0 or 4. 4. Okay, let's say it's 4th order. So what I would do is say, I write the rate law. Okay, A to the 4th. Now I put in the units. Again, we're trying to figure out the units of K for a 4th order reaction. Well, rate is always molar per second. It's the concentration per time. It's like a velocity. K is the one we don't know. And concentration is always molarity. And here it's to the 4th power. So now you just solve for K. K equals 1 over molarity to the 4th times a molar per second, which would be, let's see, 1 over molar cubed per second. Is that all right? So you do that. It doesn't matter what you can, with your friends, you do 79th order. And put 79 there, and it's the same idea. But the units of K always change with the order, so based on the order, and then you could have a order of 3.5, so they don't have to be whole numbers. So then this would be raised to 3.5, but you solve it the same sort of way. Is that all right? Okay, that's units of K. Next, let's do half-life. Check. Half-life, who asked about half-life? Was there anything specific or just overview? Overview. For half-life, and really for everything, this is in the textbook. I happen to have the reader open here, so I'm going to flip over to it. Let me say a few things about it. So half-life is the amount of time it takes for half of it to be reacted away. But the problem is, I'm going to be looking at page, top of page 91 in the reader. It's also in the textbook in the same chapter. Pretty much in every textbook has this kind of table. So what I would give you is for sure the second row and the 5th row. So the integrated rate law and the half-life formulas, you'd have that. The problem, I think for most people, this is the most intuitive half-life, because let's say you start with 16 of something. After the half-life you'll have 8, the next half-life will have 4, the next will be 2, etc. The problem with the other ones is they both have concentration terms in them. That's the initial concentration from where you're starting. So say initially it was 16, so it'd go down to 8 as you expect. But then for the next half-life, the new initial concentration is 8. And then you'd have to calculate accordingly. So it's not going to follow the first order kind of normalness. So for example, let's say we have A goes to P. And first order is kind of the easiest to calculate, usually. If you want to find the half-life, that's the natural log of 2 over K. So you just need the rate constant. Okay? But let's say, for example, you're doing 0th order. Then the half-life is the, let's see, it's A over 2K. So in both cases, you'll need K. Let's say the initial concentration is 16, whatever, molar. Okay? Well, for the first order half-life, you don't care about that. So you could just calculate the half-life. However, for the 0th order, you care about, say, the 16. So it'd be 16 over 2K for the first iteration of the half-life. Okay? Where in both cases it would go from 16 down to 8. Is that okay? To calculate this half-life is going to be constant, so it won't change. But this one, when you're calculating, say, the second iteration of the half-life, I'll do it in a different color. The second iteration, so this is the first time, would be this one. Second time for the first order half-life, no change. But second time for this one, the half-life would be 8 over 2k. Because you'd have to use the new concentration that you're at. So the half-life time is going to change at each instance. Is that okay? Okay, cool. So that's the trickiest part about it. In most cases, your average question though, your average kind of medium level question would kind of go as follows. Let's say it's first order. Then you'd have A over A naught equals e to the minus kt. So you have that half-life, or that integrated rate law, and you'd have this half-life. So for this half-life, usually what they do is say they'll give you the half-life, a numerical value, and they'll want this quantity, A over A naught, or something like that. So you have to say, okay, k equals the natural log of 2 over the half-life. And then you plug that in here for k. That'd be a pretty typical problem. So we give you the half-life, you need to find k, you need to put it in the integrated rate law and solve for something. Is that all right? So on average, that's how you use it. Yeah? Can you save that for the specific questions? I'd be happy to do that. Yeah. Okay, so we're going to move on from half-life now. Okay, next. Reaction mechanisms. Oh my goodness. Okay, this one I cannot make up an example out of my head. Do you want me to pick one, or did the person who asked to have one?
I don't have an example, so I'll score more specifically, like when you have an overall reaction with a rate law and you have to like break the elementary steps. It's kind of like working backwards.
How do you get the elementary steps if you have the overall reaction? That's your question?
Yeah.
Are you in my class?
Yeah.
Oh, we're really not going to do that, actually. Yeah, Chamberlain's kind of into that, but I'm not going to do that for this exam. If you, for fun, you can ask me afterwards. I'm happy to talk about that. Yeah. So we're good. Should I skip on?
I know someone has a PSH.
Say that again.
I know someone else asked something in relation to the PSH as well.
Oh, that's right, PSSH. Does that person have an example, or should I? I have one from the worksheet I could do. Okay, so the one from the worksheet, where did I put that? Yeah, this one. It's a harder one, is that okay? Okay. This one. You don't know it's a harder one yet, but you'll find out in a moment. Okay. What are the intermediates? Those two. They cancel out. So there's two CLs there that cancel with these two. This CCl3 will cancel with this one. Okay. So anything that cancels out is going to be an intermediate. I don't give you the overall rate law because you could just simply add these three reactions to get it if you wanted it. We don't need it per se. Each additional intermediate usually makes the problem more difficult. And there could be several at times. So you might want to start out, well, the other problem is we don't know which rate to solve for because I didn't give you any information. In this case, that will become apparent as we start to solve the problem. But at this moment, we don't know whether to solve for rate 1, rate 2, or rate 3. Okay? we might guess, oh, let's solve for the rate that has the products in it. However, this is one of the products, and this is the other. So there's a product in both rate 2 and rate 3. Okay. So let's do PSSH on each intermediate. This is where I usually kind of start and see what happens. So let's pick this one right here to do PSSH on. All right. Where is that produced? Reaction 1. Produced anywhere else? I don't think so. Okay. Where is it a reactant? Reaction 2, reaction 3, and the reverse reaction of 1. Yeah. And not only that, in reaction 1, when it's produced, 2 of them are produced. Okay? So that one's getting a little messy. Let's look at the other intermediate for a moment. I guess you could say that. That's a good point. Okay. Let's do this one right here, the CCl3. Where is it a product? Reaction 2. Where is it a reactant? Okay, that's a little nicer. Okay, so let's look at the messy one for a moment. Okay, here, like right here, you're going to have Cl squared there as a concentration. You see that? Here, you're going to have Cl to the first power. Here, you're going to have Cl to the first power. And here, you're not going to have a Cl. So you're going to have a quadratic equation. That sounds a little crazy to me. Okay? It's solvable, but probably not on an exam. So, I'm flipping to a sentence that is so easily ignored on page 100 of the reader. It says, one more thing! Exclamation. I wrote this for this exact problem we're doing right now. Sometimes for difficult problems, that's this one, you will need to use a combination of the second category, forward equals reverse, and PSSH. Try this idea if you don't know what else to do. And once you get to the quadratic here, you're going to get into a big mess. Because that one would be difficult to solve. So that at that point, I start to wonder, wow, I hope there's a reversible reaction that I can do something with. Which the first one would be that case. The second thing I want to say before we look at that, remember we were trying to decide between rate 2 and rate 3 because they both had the products. That has a product there, that has a product there. Well, turns out they're equal, so it doesn't matter which one you would have picked. Because rate 2 equals rate 3. So either of them are totally fine. Okay, so let's write this out right here. Rate 2 is K2 Cl CHCl3. Rate 3 is K3 Cl CCl3. Let me underline the intermediates. There's one there, and one there. So we still have a little bit of issue because we have intermediates on both sides of the equation. That's not so helpful. So if you had to pick which rate you were going to solve for, rate 2 or rate 3, which one would you pick? Because you know they're both equal. I'd pick rate 2 because it only has one intermediate instead of 2 of them. So let's say the overall rate is equal to rate 2, which is K2 Cl CH Cl3. However, using this equation to solve for our one intermediate will not be helpful. This equation was only helpful to tell us that, oh, it doesn't matter if I pick rate 2 or rate 3, they're both equal. Let's pick rate 2, it has one less intermediate. So looking at here, It's not helpful to get an expression for Cl from this. And it's not helpful to get an expression for Cl from this. This would also include both intermediates. So this is that. One more thing. Sometimes the problem gets so complicated because there's more than one intermediate. Use PSSH, which we did here. And a combination of the reversible part. And if I use a combination of the reversible part for reaction 1, I will get it in terms only of one intermediate, which is the one I care about. So let's do that. I'll do that at the very bottom here. We'll go to a new color. I'm going to say rate 1 equals rate 1 reverse. Why? Because the problem's too hard to solve any other way. So K1 Cl2 equals K1 reverse Cl squared. Remember, I want an expression for Cl to plug in, so I'm going to solve for Cl. Cl squared is equal to K1 over K1 reverse Cl2. Take the square root of both sides. Cl is equal to square root of all this mess. Which you could also write, if you prefer, if you don't like the square roots, you can raise it to the 1/2 power. So you can use the 1/2 powers if you prefer those. All right, let's put this out of the way. Next page. I'm going to take this expression here and plug it in for the intermediate. Okay, so let me rewrite rate 2 one more time. Rate 2 is K2 CHCl3 Cl. Again, I'm plugging in for Cl. This expression right up above. It's going to be K2 CHCl3 K1 over K1 reverse to the 1/2 and Cl2 to the 1/2. Now it's convention to put all the K's first and then all the concentrations second. So let's do that. K2 times K1 over K1 reverse to the 1/2 times CHCl3 Cl2 . That would be my final answer. So this is in the category of the tougher ones. If you can do this one, you can probably handle yourself on other tough ones. Any questions on this? I know it's a little tougher. It was one from the discussion worksheet. Yes, I'll make my way back there. Yeah.
I kind of got lost just with what you did after, like, you said R2 goes to R3.
Okay. So you're okay with this step here?
Yes.
This step here? Okay, I just plugged in.
And then were you trying to solve CL3?
It was too crazy.
Okay.
The question was I trying to solve for something? No, I had 2 intermediates here. It wasn't helpful. Yeah. So I found too many intermediates, I can't solve for one of them. That's not helpful. So the only thing I got out of this expression was that, oh, it doesn't matter if I solve for rate 2 or rate 3, they're both equal to each other. This one didn't help. I did it on this one. It doesn't help me solve for an intermediate, but it does tell me the rate 2 and rate 3 are equal.
It tells you which rate to solve.
Yeah, whichever rate 2 or rate 3, it doesn't matter. I picked rate 2 because it only has one intermediate. Yeah. Okay, yes. Why did I do this? Because I could not find an expression for the intermediate. I did PSSH on this one, that won't help me. I did PSSH on this one, that won't help me. They're both functions of 2 intermediates. So then, I have in the back of my mind, whenever things get so crazy like that, and it looks somewhat unsolvable, I go back to my reaction and see if I have a reversible one. And I'll just say forward equals reverse. So that's kind of my last ditch effort. Is somebody back there? Yes.
So is it basically if both SSHs have like multiple intermediates, then you can set the reverse reaction frequencies?
Yeah, if both PSSH have the reverse intermediate, you're not really getting anywhere, I look for a reversible reaction.
Okay.
Yes, in the very back.
What if there's no what if it doesn't tell you which reaction to solve for, but like you can't figure it out from using the intermediates?
If it doesn't tell you which one to solve for, then it should be obvious in 3 possible senses. This is the most rare, that say rate 2 equals rate 3, so it won't matter. Or, we'll tell you, or you pick the one with the products.
Okay.
Yeah, one of those should work.
Okay, yeah.
Yes?
What's the definition of an intermediate again?
What's the definition of intermediate? Something that does not appear in the overall reaction, so it cancels. Anyone else? Yes? Yes? So you're saying when I did this here in the middle of the page in black? What was your question about that? Oh, could I pick the second or the third reaction? No, because the first one's the only one who had reversible arrows. Yeah. Occasionally, like the predator-prey example we did in class, there's nothing that's reversible, and so you can't do that. But we didn't need it in that problem. This one we did, and luckily there's the first reaction is reversible. Okay, moving on. All right, we have a little bit of time left. That finishes up with kinetics. Let's do one more question. Okay, one more question. Take it back.
So we're not reusing the like left so I don't see like you're using a plugin PSSH because we're using
Yeah. Okay. Well, what's the point of confusion?
So like it's the features to use like that's why we like here and then
Okay, there's 2 different times that we would use the coefficient 2, which is this one here. The most common is when we write a rate law, let's say the reverse, then we would square because it'd be second order. However, when you're writing the rates in PSSH, like this, that we were doing earlier, if you're making 2 of them, then you have in let's say this example, we're making 2 CLs. So I need an R1 for both of those CLs. So it'd be like R1 plus R1. Yeah. Okay? Yeah, so sometimes you need 2. We also saw that in the predator-prey example. I had a 2 there, I believe. So you can double check that. As another example that had a coefficient 2 and not just a squared 2. You wouldn't need that when you go rate 1 equals rate 1 reverse, because you're just talking about rates, not a production of something in particular. So that's why you'd only use that in PSSH. All right, main group, inert pair effect. Okay, hopefully, okay, I'll say overall, this topic should feel very easy. So let me re-explain it.